Now, from our previous video, the last video we did, we described the working principle of a generator, and we said it can be described in phases, in phase angle. So the amount of EMF induced as the loop, the conductor, winds through a magnetic field is determined by the phase angle through which the conductor has rotated. Now, if you look at that, if you go back to that video, you see that at some point from 180 degrees, as the loop turns 180 degrees and beyond, down to about 360 degrees, the direction of current induced reverses, and this suggests that the current produced in this generator is a special kind of current which we call alternating current. Alternating because it changes direction periodically. So here we are going to describe the AC waveform, the alternating current waveform. Like I explained to you, the kind of current generated or induced in a conductor in this kind of generator I just explained to you is an alternating current because its direction changes periodically. It goes back and forth, back and forth, back and forth. And that's exactly what an alternating current is. That current that doesn't flow only in one direction, that's as opposed to a DC. So an AC is a current that flows, that changes its direction periodically. You see. So now we are going to define or try to find what kind of waveform would this be. So if we plot the graph of the phase angle against the induced EMF on the vertical axis while the phase angle on the horizontal axis, by the time we find the induced EMF for every degree turn, for every degree of phase angle turned, we're going to get something like this that goes in this way. It goes upward and then downward and then upward again. So where, of course, here is 0 degrees, here is 90 degrees, here's a 180 degrees, here is a 270 degrees, and of course here is 360. You see, according to what we did here the other time, here we said the induced EMF at 0 degrees, of course, is 0. And that's what you have here. At 0 degrees, the induced EMF is 0, minimum. And then, as the phase angle changes to 90 degrees, we said the induced EMF is maximum. And that's exactly what you see here. So as the phase angle rises to 90 degrees, the induced EMF is maximum. Here it peaks here. So here is E naught. And then as you continue to move from the phase angle 90 degrees to about 180, it begins to decrease until it finally comes to 0 at 180 degrees. Minimum again. And that's what you have here. When theta is 180 degrees, EMF is 0 volts. Now as you continue to move the phase angle from 180 degrees and beyond, the value begins to increase again, but this time the direction changes, and that's why we have this here. We have positive, negative. The negative sign here shows the direction of EMF or the induced current is opposed to what it was here from 0 to 180 degrees. And now from 180 degrees continue like that down to 270 degrees, then we reach a maximum again, but this time it's in the opposite direction. So this from here to here is the same thing as from here, so it's the same thing, E naught. But here we have a negative sign showing you that the direction of a current in this phase is opposite to the direction of current in this phase. You see, and that continues till we reach a minimum again at 360 degrees. So this brings us to say that the waveform of an alternating current is sinusoidal. If you go back to our videos on AC circuit, we said the AC circuit, or an alternating current can be represented in a sinusoidal form. It takes a sinusoidal waveform. Now you can understand why that is the case. You see, so it goes sinusoidally. So the AC, the alternating current waveform, is sinusoidal. 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 That is, it goes in a sine wave form in this way. So let me explain that again. So the form, if you want to represent an AC circuit, an alternating current or EMF on a graph, whereby you plot the EMF on the vertical axis and the phase angle on the horizontal axis, you're going to get a sine waveform like I just explained to you. So this is why alternating current can only be represented graphically using a sine waveform, an up and down graph. Thank you.